Hello and welcome to lesson 2.2 over logic. That's right, the name of our lesson is just logic, and we'll explain a lot about that in this lesson though. Even though the name of the lesson is short, there's a lot to talk about. So let's begin by taking a look at the things we're going to learn. Previously we've found counterexamples for false conjectures. Today we're going to talk about truth values of negations, conjunctions, and disjunctions. And we're going to represent them using Venn diagrams. We're also still going to find counterexamples as part of what we do today, but there's a lot of new vocab in this discussion of logic. Alright, before you begin to watch the rest of this video, please make sure that you've read lesson 2.2, which starts on page 99, and make sure you have your definitions written down in your vocab book for statement, truth value, negation, compound statement, and conjunction. Alright, before we begin, I do want us to take a quick look at just what you would see in your book to make sure you know these definitions. A statement is a sentence that's either true or false. So we have a lot of statements, not just specific to geometry, but any statement that we can assess as being true or false has what we call a truth value. It's either being true or false. Statements often represented using letters, and a lot of times we'll use P and Q to represent two different statements. The negation of a statement has the opposite meaning as well as an opposite truth value. And so we add the word not into a statement and it makes it the negation of. This little symbol, this tilde before the P, is how you use negation in the symbols. And then in the sentence or the statement you put in the word not. When we put two or more statements together joined by the word and or, we get a compound statement. Compound meaning two things or more put together. So a compound statement using the word and has the name conjunction. A conjunction is true only when both statements that form it are true. If we're using the word and, that means both of them have to be true for the overall statement to be true. So let's take a look at our examples. We're going to use the following statements of P, Q, and R for the next parts of example 1, these three parts, A, B, and C, to find out what the compound statement is for the conjunction and what the truth value is, true or false. Remember, truth value is either true, T, or F for false. So let's take a look. They first want us to take a look at P and Q. So we're going to make a compound statement joining the statements P and Q. P is 1 foot is 14 inches. Q, September has 30 days. So this is what your compound statement should look like. 1 foot has 14 inches and September has 30 days. In order for this statement, the whole sentence, to be true, both of these parts have to be true. Now, while September does have 30 days, 1 foot does not have 14 inches. Since this first part, P, is false, then our conjunction, P and Q, is false. For part B, we're doing another conjunction. Remember, conjunction uses the word and, but a lot of times we will replace the actual word and with this symbol. This symbol is our symbol for conjunction, and it literally means the word and. Now, you may remember this symbol from a few moments ago. That tilde in front of the P is our negation. And it means we're going to add the word not into our statement for P. So once again, we're using P, 1 foot is 14 inches, but I have to negate that. I have to say 1 foot is not 14 inches. And then we're going to use R. A plane is defined by 3 non-collinear points. Notice the negation only applies to P, not R. So let's go ahead and take a look at what that compound statement that is a conjunction should look like if we say if not P and R. 1 foot is not 14 inches and a plane is defined by 3 non-collinear points. Now remember, we already said earlier that P, as it's written here, is false, so the negation of P has to be true. So we know 1 foot is not 14 inches is true. And our second statement, R, a plane is defined by 3 non-collinear points, that is true. So since both P and Q are true, since not P and R are both true, the conjunction not P and R has a truth value of true. All right, let's move on to part C. I want you to take a stab at trying to write the conjunction not Q and not R. Notice we've negated both, and we're using the and conjunction for statements P, Q, and R. Take a moment, pause the video, give yourself enough time to write this conjunction, and then we will continue and see what the truth value is. All right, we should get the following conjunction. Since the negation of Q says a square does not have 5 sides, and the negation of R says a turtle is not a bird, our conjunction is a square does not have 5 sides and a turtle is not a bird. Now, the negation of Q has a truth value of true. A square does not have 5 sides, it only has 4. The negation of R, a turtle is not a bird, is also true. Turtle's not a bird. Since both parts of our conjunction are true, this has a truth value of true. And that brings us to our next form of compound statement called a disjunction. Conjunction uses the word and, disjunction uses the word or. For a disjunction to be true, one part or the other must be true. Not both, only one must be true. But if they're both false, then your disjunction is also false. So let's try and form some disjunctions. We are given these 3 statements. Segment AB is proper notation for segment AB. Centimeters are metric units, and 9 is a prime number. We want to come up with a disjunction of the statement P or Q. So that means we are going to start with saying the statement from P and there's our one sentence statement that is a disjunction of P and Q. Now, in order for this to be true, one or the other of the 2 partial statements must be true, not both, at least one. Since AB is proper notation for segment AB, that is true, we can already tell that this statement is true. Centimeters are metric units, that is also true, but all we need is at least one. All right, let's try part B. Again, using the same statements, we're going to write the disjunction Q or V. I'm sorry, Q or R. This symbol literally means the disjunction or. Okay, so it's just an upside down symbol for and. It means the opposite of and, which is or in this case. So we're using Q and R. Why don't you pause the video and write that disjunction? All right, this is what we should get. Centimeters are metric units, or 9 is a prime number. That's your disjunction. Now, even though the second part of this, R, is false, this is still a true disjunction since at least one part, Q, is true. All right, why don't you take a stab at part C, and we'll come up with our result in just a moment. All right, this is what we should get. AB is not proper notation for segment AB, or 9 is a prime number. Now, the negation of P is actually false, since we know P itself was true. The negation is false. And R, we remember, is false. Since both parts of this disjunction are false, our overall disjunction is false. to quickly review, negation is a statement that has the opposite meaning and truth value of the original. So we read the word not P and we write the tilde before the P. A compound statement formed by joining two or more statements using and is a conjunction using this symbol. A disjunction uses the word or and that symbol. Now let's move on to talking about truth tables. Truth tables, you may recall from your reading, are a convenient method for organizing the truth values of statements in a table form. And we can use them to organize truth values of negations and compound statements that are conjunctions and disjunctions. So let's take a look at constructing a truth table for not P or Q. Now, here's how we construct our truth table. The statement P, whatever it is, even though we don't have a specific statement, P could be true or P could be false. But if P is true, Q could also be true, or P could be true and Q could be false, or P could be false and Q could be true, or they both could be false. We have those four possible combinations of true and false. If we have a statement P, the negation of that would be the opposite truth value of each of these. So the opposite of true is false for negation of P, and again false there. But the negation of P if P is false is true, and true there. So we take the opposite of each of those because negations have the opposite truth value. So if not P or Q is our disjunction, then remember the word or, disjunctions, you only need at least one of not P or Q to be true. So I'm going to look at the rows, and I'm not going to completely ignore this, but I'm going to cover up this segment for the time being. As long as one of these two is the letter T, then the disjunction is true. But both of these are false, so our disjunction is false. Both of these are true, so that's true, and at least one is true. So there's really only one way for a disjunction to be false, and that's if they are both parts false. Alright, we are actually going to try and let you do part B on your own. I'm going to display the answers in just a moment, but I'll go back over in class. But the answers you should get for part B should look like this. If you need more time, pause the video. Otherwise, this is what you should get for part B. This is our truth table for part B. Alright, let's move on to talking about Venn diagrams. You guys are familiar with Venn diagrams, but we can incorporate more than just the two circles to represent different sets. We can have as many diagrams as we can cram in there. Most of the time you'll see 2 or 3, no more than that. So, this Venn diagram shows the number of students enrolled in Monique's dance school for tap, jazz, and ballet. The 3 different categories are there. How many students are enrolled in all 3 classes? Well, the intersections of all 3 circles give us this small space here, and we would call this the conjunction of all 3 sets. Students that are in tap, jazz, and ballet. The conjunction of all 3 is a set of 9 students. Part B asks how many students are enrolled in tap or ballet. That is going to include all of the students that are either in tap or ballet. So we're going to include all the numbers in tap and all the number in ballet and add up these 6 numbers. When you add 28, 13, 17, 9, 29, and 25, we get a grand total of 121 students. And lastly, how many students are enrolled in jazz and ballet but not tap? So jazz and ballet. So I'm going to include jazz and ballet. And means just the part that's overlapping, but not tap. So not in the middle part here. So we're just looking at the number 25. Alright, that wraps up our lesson on logic. We'll talk a lot more about this in class on Friday, but you should have enough to get started on the assignment when you show up in class.